A right circular cylinder just encloses a sphere of radius r. So, they said a given right circular cylinder, this is how a right circular cylinder look like. Okay, a right circular cylinder encloses a sphere of radius r. So, inside this a sphere is present. My sphere doesn't exactly fit. Draw in such. This is how it look like. So, a right circular cylinder just encloses a sphere of radius r. Now, this has a radius r. They are asking us find the surface area of the sphere. So, we know the surface area of a sphere is 4 pi r square because the radius is r. Now, they are asking us to calculate the curved surface area of the cylinder. Now, again here cylinder is out of your scope, but for understanding this problem let us discuss. The curved surface area of a cylinder, the formula for curved surface area of a cylinder is 2 pi RH. So, you know the value of pi, radius also known, which is r over here, and h. What about h? Now, look, this is the height. This is the height of this particular cylinder. Okay, and this is the radius. So, what will be the height? Check this r from here to here. This is the radius. Here as well, it is radius. So, height of the cylinder is 2r, and the radius is already r that we know. So, 2 pi r value is r itself, height is 2r. So, you have 2 2s are 4 pi r square. So, this is the curved surface area of cylinder. Now, they are asking us to calculate the ratio of equation 1 by equation 2. So, you see you have 4 pi r square, 4 pi r square divided by 4 pi r square. So, if you cancel it out, you have 1:1. So, this is the ratio of the areas of both the figure. So, both of them resemble a formula for a sphere. I hope you understood, and this ends the entire playlist for your exercise 11.2. Thank you.